I'm going to work up a brief sieve of Eratosthenes. Um, so it's going to be the sieve, and I hope oh, there we go. Hope I spell it correctly. Oh, yeah, I knew I was going to make a mistake there. There we go. Yellow sieve of Eratosthenes. Now, if we start with the numbers, this is, of course, in the natural numbers. So beginning with 1, dot, dot, dot. And if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then let's just do the first 20 numbers. Okay. Little interruption there from other things running on this computer. If you look at just 1 to 20, we know that 2, 3, 5, 7, 11, 13, 17, and 19 are prime. So at least we're 20% there. Of course, we all know that 4 is equal to 2 squared, 6 is equal to 2 times 3, 8 is equal to 2 cubed, 9 is equal to 3 cubed, and 10 is equal to 2 times 5. 12 is equal to 2 squared times 3. 14 is equal to 2 times 7. 15 is equal to 3 times 5. 16 is equal to 2 to the 4th. 18 is equal to 2 times 3 squared. And 20 is equal to 2 squared, which is 4, times 5. Right? So that takes care of the first 20 natural numbers, 1 to 20. And we found these primes. Now, of course, now we start looking at a pattern where we can get a lot leaner in what we do. So number 1, 2 is the only prime even number. So anything that ends with a 2, anything that ends with a 4, anything that ends with a 6, anything that ends with an 8, and anything that ends with a 0 is all even. So we don't need to worry about these columns of numbers. Also, every number that is a factor of 5 ends in a 5. All right, so now when we narrow down to the next range, we start with 21, we can really go fast. Why? Because we can do this. We can do 21, we can do 23, 27, 29. So I'm going to just write down these 4 columns. Well, actually, I ran out of space down here, but I'll do some more somewhere else. Yeah, that distracted me a little, so I'll have to do some erasing. Okay, fine. Go back to yellow. So we can do a few down here, and then we'll continue on the right-hand side. Okay, so let's go to 50, and then keep going to the right. All right, so we can see right here, we already know, I think it's pretty obvious to see that 23 is a prime and 29 is a prime, and so is 31. Okay, now 21, we know it's 3 times 7. 27 is 3 cubed. Okay, so these are not prime. 33 is 3 times 11, not prime. 37 is prime. 36 would have been good, but it's even. 39 is 3 times 13, so it is not prime. 41 is prime, 43 is prime, and 47 is prime. This is a very nice pattern that does not happen too often, where we have two consecutive prime pairs. Very interesting pattern there. And then, of course, 49 is 7 squared. So that has taken us all the way to 50 for the sieve of Eratosthenes. And we're only 5 minutes in. All right, so then, do I have space up here? I sure do. Great. So then let's continue in this corner and go on to 51. I'm going to double check that I did the exact right thing, right? So we did all the way to the 40s. Now we're going to do the 50s, 60s, 70s, 80s, and 90s. This gets a lot more interesting. Again, always 1, 3, 7, 9. That's what we really are doing here. And by the way, this is a very common starter discussion in number theory. You'll find this, the sieve of Eratosthenes to 100 in pretty much every intro number theory book, at least the ones that I have seen. Now, there's some easy stuff here, but 51 and 57 are my favorite boogeyman numbers because many times in my early number theory learning, I have convinced myself that 51 or 57 are prime numbers. But the way to see it clearly is that 51 is 30 plus 21 and 57 is 30 plus 27. Now, in the case of 51, this is 3 times 10 plus 3 times 7, which equals 3 times 17. And this is 57, meaning 3 times 10 plus 3 times 9, which equals, hold on here for a second, which equals 3 times 19. All right, so we took care of that right there, 51, 57, not prime. But 53 and 59 are prime. Things like what does lead to 59? So let's just try something. Like you would say, is it divisible by 3? It is not, because 5 is not divisible by 3. Okay? 61 is prime. 63 is 7 times 9. It is not prime. 67 is prime. Sorry about that. I always forget to use the backwards thing instead of the eraser. I should start doing that. And 69 is 3 times 23. So it is not prime. 71 is prime. 73 is prime. 77 is 7 times 11, not prime. 79 is prime. Okay, so now we're down to our last few numbers. 81 is not prime. Why? 81 is equal to 9 squared. Okay, a little tight here. Let's zoom out and see how far we've covered of every space that we have in this file. Oh, okay, so we're running out of space, but I think we can fit it in, because I can go in here and say 83 is tricky, and so is 87, but 89 is a prime. All right, so let's do 83 and 87. Maybe we do a little erasing here, since I already said the name of this sieve was the sieve of Eratosthenes. So, all right. I don't know why. Oh, it's doing that thing. Okay. It's one of those pen stroke things. Okay, so then that's a brighter yellow. So 83 is equal to what? 33 plus 50? That doesn't work out. That doesn't work out at all. What was 83? What was 83? It's not 63 plus 20, right? It is actually prime. Mistake there. So 83 is prime. Let's go do some more erasing, because 83 is prime. Okay, so then 87 is 60 plus 27, which is equal to 3 times 20 plus 3 times 9, which is equal to 3 times 29. So 87 gets scratched out. Now 91, easy, it's 9 squared. 99, easy, because then I'm going to put it in here. I'm running out of space, is 9 times 11. Okay, then what about 93? 93 is divisible by 3. 93 is equal to 3 times 31. But 97 is prime. So there you have it. Those are the primes to 100. And I have factored out every single number that is a composite.